Question 7. A student reacts small chips of calcium carbonate with an excess of dilute hydrochloric acid. This is the student's method. Add 5 grams of small calcium carbonate chips to a conical flask. Add 30 cm cube of dilute hydrochloric acid, which is in excess. Quickly add a cotton wool plug and place the conical flask on a balance. This is the equation for the reaction. The reading on the balance decreases as carbon dioxide gas is lost through the cotton wool plug. Question A. Calculate the mass reading on the balance when all of the calcium carbonate has reacted. Assume that all of the carbon dioxide gas is lost through the cotton wool plug. Okay. So we have to find the mass. Okay, so first of all, I will find the mole of calcium carbonate first. So mole of calcium carbonate equal to mass divided by mR. Okay, so mass of calcium carbonate is 5 grams. Okay, so I will put 5 here divided by mR, which is 100. So it is equal to 0.05 mole. Okay, then if we go back to the equation, the coefficient of calcium carbonate and carbon dioxide are equal, which is 1. That means that the mole of calcium carbonate must be equal to the mole of carbon dioxide, and it is equal to 0.05 mole. Okay, so therefore mole of carbon dioxide gas equal to mass divided by mR of carbon dioxide. So if we want to find the mass, it will be equal to the mole of carbon dioxide times mR. So mole is 0.05 times mR, which is 44. So therefore, mass of carbon dioxide is equal to 2.2 grams. Then the reading on the balance will be equal to 122.2 minus 2.2. So it is equal to 120 grams. So the answer is 120. Experiment with a different mass of calcium carbonate and a different volume of dilute hydrochloric acid. The hydrochloric acid is in excess. The student records the total mass of carbon dioxide produced at 1 minute intervals for 8 minutes. The table shows the student's results. Okay, so I plot the student result. The first 3 have been plotted for you. Okay, so we will have 1.64, so it will be this one. Okay, 1.64, and then 1.72 at 4, 1.68, 1.72, and then 1.76. Okay, and then 1.8 from 6, 7, and 8. So 1.8. That's it. Then next, okay. Question II. Draw a curve of best fit through the points. Okay, so it will be like this. Let me draw again. So Okay, then calculate the rate of reaction at 2 minutes by drawing a tangent to the curve and calculating the gradient of the tangent at 2 minutes, right? So okay, so I will have this point, which is, and this point. Okay, so the gradient of, the coordinate of this point will be 2.2 and 1.44, and this point will be 1.8 and 1.242832 1.32. Okay, so it is equal to, gradient will be 1.44 minus 1.32 divided by 2.2 minus 1.8. So we will have, let me use 1.44 minus 1.32, which is 0.12 divided by 2.2 minus 1.8, which is 0.4. So 0.12 divided by 0.4 is 0.3. That's it. And okay, explain why the shape of the graph changes during the 8 minutes. Okay, because why the shape of the graph changes, right? Okay, 4 marks. First one is the curve is steepest at the start because the reaction is fastest. Then the curve become less steep because the reaction slows down. Okay, then question C. The student repeat the experiment using the same mass of calcium carbonate but as powder rather than chips, keeping all other conditions the same. Explain the effect of this change on the rate of reaction. So the rate of reaction increases because the surface area increase. And then there are more collision per unit time.